The first problem type we will solve is to find the root or the roots of a single nonlinear equation. And in this slide, I have put up two examples. One is related to the mass balance for a pollutant in a well-mixed lake. The equation can be written as you see there, V dc by dt, that is the accumulation, and this is the inflow, W, this is the outflow, QC, and this is the reaction term. All right. So in any case, without even getting into those details, we have this equation, a differential equation of the first order. V dc by dt is equal to W minus QC minus K times V times square root of C. Now, in fact, the square root of C makes this nonlinear. So given the values of V, the volume of water, let's say in the lake, the outflow rate per year, Q, the amount of pollutant that comes in every year, W, and the reaction rate constant K in these units. Now the question asks us to solve for the steady state concentration, CS, right? So what is the steady state value of C, which is described by the symbol CS? So at steady state, what happens is dc by dt is equal to 0, and therefore we have 0 is equal to W minus QC minus K times V times square root of C. And given the values of W, Q, K, V, we have to find the value of C. That's the question here. All right, and the answer we get, we will just call it the CS, the steady state concentration. Okay, so that is the first problem. The second problem relates to channel flow and environmental engineering. So flow through channels. So these are the symbols that are in those equations. So you see the symbol Q, S, N, B, and H. So you have 5 symbols and you have this equation, the relationship between those symbols. So what you do is, the problem here is given the values of Q, S, N, and B. So you're given the value of Q, S, N, and B. You are asked to find out the value of H. So as you can see, right, there is non-linearity because there is division. All right, there is division of H to the power of 3 by something that involves 2H to the power of 2 by 3, right, plus B, etc. But then this makes it non-linear. So given the values of Q, S, N, and B, finding H is going to be involving solving for the root of a single nonlinear equation. This equation is nonlinear, whichever way you represent it. This equation will be nonlinear, and there is just one equation. So it falls into this class of families. Now, as we go along, right, we will learn many techniques for solving the roots of the single nonlinear equation. But what we would emphasize on is something called the Newton method or the Newton-Raphson method of solving for the root of a single nonlinear equation. So we will learn many approaches, but I will stress very much on the Newton method or the Newton-Raphson method, simply because that scales to solving a system of nonlinear equations, which is very, very important for us. All right, we will get to that eventually. But here, I just want to say I'll try to solve the first problem. So as you remember, dc by dt is equal to 0 at steady state. Therefore, we have this equation as I explained. Note that because we are solving for the steady state concentration C, I have used the symbol CS instead of C in the equation. Now, I substitute the values of W, Q, K, V, etc. given in the question, right? And then I divide throughout by 10 to the power of 5 after making sure the units or consistent, etc. Right? That is always very important to check for the consistency of units so that we do not miss out any term inadvertently, right? And we solve the wrong problem, right? So there is no greatness in solving the wrong problem correctly. So we always have to be very careful to check consistency of units and things like that. So in any case, I do not want to carry these big numbers 10 to the power of 6, 10 to the power of 5, etc. So I realize that I can divide by 10 to the power of 5 on both sides. So this is the equivalent system. Now I can solve it in a few ways. I'll demonstrate a couple of ways of doing it. One is I'm just going to let square root of CS, I'm going to call that as x. So this will become x squared. This will become 2x. So when I do that, I get this quadratic equation. Of course, you can solve the quadratic equation by hand, right? We know how to solve ax squared plus bx plus c is equal to 0, right? We have been taught in school that x is equal to minus b plus or minus root of b squared minus 4ac by 2a. So here a is equal to 1, b is equal to 2, and c is equal to minus 10. And therefore we can solve for the values of x. So this is how we solve it analytically. Luckily we have a quadratic equation, so we can do that. But when you have to solve it, let's say numerically, we can make use of the roots command in Matlab. So the roots command in Matlab works for polynomials. Like we have a second order polynomial here. Therefore, the roots command will help us to solve the nonlinear equation if the nonlinear equation is of the polynomial type. So all I do is roots, ordinary brackets open, and then within square brackets, I just give the coefficients starting from the coefficient of the highest power, which is this problem is coefficient of x squared, which is 1, then the coefficient of x, which is 2, and then the constant term. So you just type out the coefficients in the decreasing order and end up with the constant term in the equation. And then square brackets close, and then ordinary brackets close. So when you press enter, Matlab will give you two answers, right? So these are the two values of x that you would have gotten in this particular case by looking at the analytical solution also. But Matlab does it effortlessly for us. All right. So once you've got x, then we know x squared is equal to cs. So I can take these answers and square it up and get the two values of cs that will work. Okay, that will work for this particular equation. Now, one of the equation makes sense because we do not want CS to be negative. That's one thing, but we also do not want the square root of CS to be negative also. All right. So we get the two roots. Those are mathematically correct roots, but we should always look for the one that is physically meaningful. So we would say that the root which gives you CS is equal to 5.3668 is the physically meaningful answer to this problem. Okay, this one CS is equal to 18.6332 is mathematically correct, but it comes from this root which is minus 4.3166. So its origin is not good, and therefore we do not take that to be a physically meaningful answer to the problem. So this is something that I want to share with you on this particular aspect. Now, in general, right, nonlinear equations may not be of the polynomial type. It just so happened here it is of the polynomial type, but it can be a non-polynomial type. For example, you can have equations like 1 plus 3t minus 4 e to the power of minus 3t is equal to 0. This is not the polynomial type, right? So how do you solve this? So this is where Newton-Raphson technique or Newton method can become quite useful for getting the value of t that makes this true, this equation true. So in Matlab, the command is f0. So f0 is the command, function 0. See, we are trying to find out the 0 of the function. That means at what value of x will this function become equal to 0? That is what is called the root, right? The value of x that makes the equation 0, that's called the root. So you can also call it the 0 of the function. So the command is f0 and then ordinary brackets open at x. Basically, you're trying to tell f0 that the symbol that we are seeking answer for is x. So we are going to type out an equation that is a function of x. So at x, right, we have to just get used to the syntax, and also there could be options. This may not be the only way of calling f0. So you can call f0 in other ways, right? Using the function within single quotes, etc. So you need to explore all of that stuff, right? So what I'm going to give you is one way of doing it. I don't want to say that's the only way of doing it, right? So the more you know Matlab, you will develop your own programming style and the way of calling functions, etc. So develop that and use it to solve the problems correctly. So in any case, so at x, then I'm going to type out the function. So this is the function f of x. So as you can see, 10 minus x minus 2 times square root, sqrt is the function for square root in Matlab. So square root of x. So the star is important to just tell Matlab you're multiplying 2 with the square root of x. And square root then you put the square root and of x, right? You put that in brackets like this. And always balance the opening brackets with closing brackets. So this closing bracket closes this one. Okay, done. So we have told f0 that the function is going to be a function of x, and in fact the function is exactly this, and then comma, then we give an initial guess. This is the initial guess. I believe that the answer is going to be closer to 3, either from process knowledge, or I can look at the equation and say, well, I think I'm going to have a root near 3. So initial guess is something that you get from knowing the system well or by knowing mathematics well. Both of it can give you a good initial guess. A good initial guess is always important while solving for nonlinear equations, because your initial guess value can decide whether the system finds you the answer, whether the function f0 finds you the answer or not. Because the methods are not known or guaranteed to converge for all initial values or initial guesses that you provide. So if your initial guess is good, then the function f0 will find out a good answer for you. Otherwise, it might just not do it, as we shall see later. So when I did that, so after the initial guess, I closed the bracket. So this bracket closes this one. So I just press enter, and then you get x is equal to 5.3668. Exactly the one of the roots that we got, right? By doing the problem in a different way, we got cs is equal to 5.3668. Now here, f0 function gives it directly. So this is one of the roots it finds, starting from our initial guess. So it takes our initial guess, and f0 has an interesting algorithm which is based on the Newton method that I've been talking about a few times. We will see the exact equation for the Newton method later. But what it does is it takes the initial guess and tries to improve it, tries to improve it, tries to improve it over a few iterations. And the moment it finds a good enough answer, it will echo it out for us and store it in this variable x, which we can display and get it here. So 3 seems to be an initial guess, a good initial guess for this problem. Now, what I also did is I do the same function now, exactly the same things, but my initial guess is 25. So again, f0 takes me to the value of x is equal to 5.3668. So that is wonderful. And as a last illustration, I wanted to do the same thing, but now I wanted to give an initial guess of 2. I think the value of x is close to 2. So I just gave it that value. Now what it did was, after doing some iterations, it comes out with a message, an error message saying, I'm exiting f0 because I'm aborting the search for a root. So it says I encountered some complex numbers and therefore complex function values during the search. So 2 was not a good initial guess. 3 was a good initial guess. 25 was an good initial guess, even though 25 is very far from 5.3668 compared to 2. So 2 did not turn out to be a good initial guess for this algorithm. So it gave the answer NaN, which is not a number. So what we learn from here is the importance of good initial guess. And sometimes, see the root here, right? This is the root, 5.3668 is the root. Now if your initial guess is 3, it reached the root. So this initial guess is within the domain of attraction of the root. So it's like, uh, planets and, things like that, right? So anything that comes within that domain of attraction, gravitational attraction, it will be drawn towards the Earth, for example, right? If it is beyond that, it's outside. Initial guess of 3 is within the domain of attraction, and therefore it is pulled to the root. Plus 25, which is somewhere here, is also within the domain of attraction. It was drawn towards this root, and that is why you got the answer. All right. But 2 is here, right? 2 is here. And these are not drawn to scale, of course. So 2 is here. 2 is outside the domain of attraction of this root. So that is why it did not converge to an answer. And we would not know the domain of attraction of any root a priori. So we can map it out by trying various choices. We can say what constitutes the domain of attraction for this problem. We would never be able to say a priori. So the question is, how do you design algorithms, if you can, that enlarges the domain of attraction? Then we could get away with a poor or a decent initial guess. We do not have to be very good at providing the initial guess. All right. So what I introduced you to in this video segment is at least two problems that involves the solution of a single root of a single nonlinear equation. Then we looked at two commands that can help us to solve. In this case, the roots command was employed because luckily our equation turned out to be a polynomial equation, in fact, a quadratic equation, right? So cubic equation, quartic equation, quadratic equations, etc. could be solved using roots. Even if you have a x to the power of 10 plus b x to the power of 3 plus 7x, right? Or let's say cx is equal to 0 can be solved using the roots command. If you give the values of a, b, and c, and then you type in like a 0, 0, 0, right? Because this is x to the power of 10, x to the power of 9, x to the power of 8, x to the power of 7. All those things are not there. And at some point in time, you say um, b. When you come to the cubic term, you type the value of b, and then 0 because there is no x squared, and then c value, and then you do not have the constant term. So you say roots of this within ordinary brackets. You can solve polynomials of this type. So roots is for that. And for general single nonlinear equations, and later we will see systems of nonlinear equations as well, F0 or an equivalent command works quite well. So you should be now comfortable using F0 command. And the optional problem in assignment 2, I believe, can be solved using the F0 command. That is something that you can try. Thanks for your attention. I will catch up with you in the next video.